Head's gone.
Right. All right.
Cool.
How much time you got?
About an hour or so.
Ballpark. All right. 3, 2, 1. Valerie Rapson.
Yes.
Can I say why I think right now is the best time? 2018 is the best time to be an astronomer, and I think you got the coolest job.
My job is definitely awesome. But go ahead. Tell me why you think it's awesome.
Well, for the first time in my life, I'm seeing that people actually seem to care about outer space.
Yeah.
Like, just people talk about it,
Right.
and people are looking up at the skies like, whoa, that's still there. Mm-hmm. So there's just that anecdotally. But then also, we have a crazy president who wants a space force, which is an incredible idea. Mm-hmm. Like, please, like, who knows what's going to come from that? Like, who knows what kind of other gadgets and inventions and innovations and knowledge is going to come from that sort of thing when we really put our government minds to that, our money towards that kind of stuff. Number 2 is like Neil deGrasse Tyson's book, The Astrophysics for People in a Hurry. It's been one of the best sellers in the world for well over a year. Yeah. Such an awesome book. I've read it twice so far.
Nice.
And just locally, we have Siena College, who they have a
brand new observatory.
New observatory.
It's bigger than our new observatory.
No, you're supposed to let me lead up to that. I was just going to lead up to that.
I'm sorry.
I was just going to lead up to that. But I know you're so excited for it.
I know.
So, yes, we have Siena College, who has their observatory. Is it up now?
Yes, it is up now. I don't know that it's officially open yet. I believe that comes next month.
All right. But then there's also someone else who has a brand new telescope.
That would be me. Very excited.
miSci, the Dudley Observatory at the miSci in Schenectady.
Yep.
Please tell me how excited and the process to get to this telescope. You and I talked about this about a year or so ago.
We did. Yeah, I think it was over a year ago. It's been going on for a long time. So I've been there at the observatory 3 years now, and they have been planning this, for like the last 10 years. They've been looking for a home, they've been looking for some land, trying to figure out where the best spot is, but finally they settled down at miSci, and now we have this awesome building. It kind of looks like a shed, and I hate to say that, but that's really what it looks like. But it's a really fancy shed where the roof rolls completely off the top, and then we've got our telescope on the inside. So it's a little separate building right next to the museum. It's really cool.
Wow.
Yes.
That's very exciting. Well, there's nothing wrong with it looking like a shed.
Yeah, I mean, that's what we have to call it more for insurance purposes than anything. But because it really isn't a building like you would think of. There's no insulation. There's no plumbing. The only thing we have in there is electricity, so we can operate the telescope and roll the roof off. But it's not climate controlled. It's not intended for somebody to be in there for long periods of time. The goal is to just go in there, open up the observatory, look at the stars for a little while, and go home.
How big is this telescope? Not that with that question, you'll have to explain to me the different sizes of telescopes and what you're able to see.
Yeah, so this is a 14-inch telescope. It's a Celestron brand, which is a really good brand. And 14 inches is great for pretty much anything normal that you want to look at. So you can see stars, planets, the moon, some of the nearby galaxies. You can see nebula, stars that have exploded. All sorts of stuff. 14 inches is like a little bit better than your standard backyard telescope, but we're not quite getting into research grade size telescopes yet, so it's a perfect middle ground where we're going to be better than what most people have, but we're not looking to be a professional research institution, so we don't have to have the biggest telescope.
So this is for people like just blokes like me coming off the street and want to look at stuff.
Yeah,
right?
Exactly. I mean, we are intended to be a public observatory, right? And you mentioned Siena. They have a big telescope. I think it's like 26, 28 inches. It's huge. It's really big compared to ours. And theirs is going to be open to the public as well, I understand, but it's meant for the students to do projects and for them to do actual scientific research with, which is fantastic. Ours is meant for the public. You can come on Thursday nights or Sunday afternoons. We do solar observing on Sundays. And you can look at stuff and ask us questions and just be amazed at what you're seeing. And you actually get to put your eye up to the eyepiece. You're not looking at a screen. You're not looking through a camera picture. You are actually seeing the object yourself.
Ooh, so you're kind of in charge.
Yeah, exactly.
So what is solar observing?
Yeah, so solar observing is when we buy a special filter to put on the front of the telescope and we can point it at the sun. Because normally if you do that, you melt the telescope and you melt your eyeball. So it's not a good thing to do.
Who do you think was the first person to figure that out? Do we know that person's name?
Well, we do actually. A lot of historic astronomers, I guess I don't know exactly which one, but I know Galileo did it, and a lot of historic astronomers, they were trying to count sunspots, the little black spots that are sometimes on the sun, So they would point their small spyglasses up to the sun to try and magnify it, and they all got eye damage over the years from that. So they learned pretty fast. We don't do that anymore. So I promise nobody's going to have burnt eyeballs. If they come and visit me on Sundays, you're not going to go home with a burnt eyeball.
Expensive filter takes care of that.
Exactly. Yeah, so a very expensive filter. It blocks out over 99.99% of the light, literally that much. And it only lets through a tiny fraction so that it's safe to magnify the sun and then look at it.
So were these guys, like Galileo and whoever else had these telescopes back then, did they know they were looking for sunspots? I
don't think they really understood what they were. They knew that occasionally there was sunspots on the sun, like these little black dots, but they didn't know what we know now. They're storms. They're places where the magnetic field of the sun breaks out of the surface and creates a little swirling storm. But there are records back down into the 1500s where people were counting them and noting where they were on the sun to try and figure out what they were. But it was much later on in history that we actually understood it.
So will people that go to the observatory see sunspots? Are they really common?
They are fairly common. Right now we're in what they call solar minimum, so the sun hasn't been as active. I think we went almost a month and a half without any sunspots. So the sun just looked like a yellow, boring disk in the telescope, to be honest. But now there was a couple sunspots last week. I didn't check today to see if there are any, but they come and go on a daily basis. So today might be different than tomorrow. And if there are sunspots, our telescope can definitely take a look at them.
How long do they last? Because all I know, that one of my favorite things I learned a couple years ago was that it takes the light from the sun to reach Earth 8 minutes.
Yeah.
So this light that we're getting right now that's reflecting off of our faces, it left the sun 8 minutes ago.
Yeah.
So does a sunspot last 8 minutes? Or is it like...
good question.
You said it was a storm.
Yeah, it's a storm. So no, they tend to last more like a week or so. Ooh. So they'll get generated on the sun, and then we'll see them either form in front of us, or sometimes they form on the backside of the sun. So as the sun rotates, it'll start to come into view so that we can actually see it. And they usually last about a week or so, and then they kind of dissolve back into the sun.
Whoa, that sounds like it'd be really fun to see it coming around the sun. How long does the sun? How long does it take for the sun to rotate?
It takes about 25 to 30 days to do that, and that depends on where you are. The sun is kind of neat. If you think about the Earth or like a solid object, right? Everything is rotating at different speeds, but it rotates as a rigid body. The sun, since it's a plasma, the middle part, it rotates at a different speed than the North and South Pole. So the middle part actually rotates faster, and it kind of coils up the plasma, which is what drags the sunspots around, and it pulls them down to the equator. Is really cool to watch.
That's crazy that we figured this stuff out. So you're saying, okay, so let's say that the center of the sun is moving like this, and then the outside, the plasma, is just getting dragged along with that?
Yeah, so think about it more like, if you think about my body, it'd be like my belly button wrapping around my body and my head rotating more slowly. So it's not inside and outside, it's top and bottom. The equator, the middle part of the sun you observe actually spins around at a faster rate than the North and South poles. So it kind of drags it around.
Oh man,
That's neat.
I need more sun information, because that's one of the ones that I keep kind of like pushing to the side, because one, I can't look at it.
Sure. Yeah, you gotta have glasses, you gotta have something special.
But we figured out a lot about the sun, and having these filters, I guess.
Yeah, that helps now. I mean, we can look at it anytime we want with these filters, and there are professional telescopes that only ever look at the sun, so they're tracking it 24/7. There, you can go online and get today's picture of the sun from a whole variety of telescopes.
It's a little bit bummer you guys didn't have this for the solar eclipse last year, right?
That would have been cool.
Timing.
I know. I mean, we still had a great time at the solar eclipse, but yeah, it would have been neat to have this new observatory up then. But there will be another one. There's always another eclipse coming.
Did you go see that anywhere special, or were you at the observatory?
I was here. We actually had 1,400 people come through the observatory, which was a record for the museum. The total number of people in one day. So we had a lot of people there. I had tons of volunteers. We all had telescopes with the filters on them. So people got to see the sun, just not through that large of a telescope.
Were you guys... Wow, this goes back to my original thought about people just seeming like there's an interest now just among just common folks. Like, were you anticipating 1,400 people? I
mean, we knew that there would be a lot, but we really didn't know if a lot was a couple hundred or 5,000, because people had the opportunity to go and travel. I mean, Schenectady, New York was not the ideal place to observe the eclipse. You wanted to be down south in the path of totality. So we weren't sure how many people locally would travel versus how many people would want to come to the museum. Because it's also something you could have just looked outside from your backyard at, too, as long as you had the right glasses to wear. So we were really happy to see that people actually came out and, got to experience it with other astronomers. I think that was the real benefit, as I was there to answer any questions you wanted about what was going on.
And you must love that.
Oh, yeah, I totally love that.
That's the purpose of your job.
Yes, please come and ask me questions. I absolutely love it when kids get excited and they ask me crazy questions, and the parents are always looking at me and saying, thank you, I had no idea what they were talking about. And it's like, I'll answer your black hole questions, I'll answer your sun questions, whatever you want.
What's the coolest thing people want to see in the telescope?
Oh, yeah, so we haven't done a lot of public nighttime observing yet, but people are always intrigued with other galaxies. So Andromeda is one of the ones we could see, and I think it really puts where we are in our lives into perspective when you're looking through a telescope and you're seeing another galaxy 2.5 million light years away and thinking, wow, that's us just in another galaxy. It's a whole nother world out there. So people love that, and they also love to see the planets. Everybody is impressed with Saturn every time. When you see those rings around, they're like, no, that's Saturn. I'm like, yeah, that's real. It's not a sticker, I swear. It looks like a little sticker that we put on the side of the telescope, but it's really not.
It's like just saying that, it brings me back to the first, even just the fifth time I've seen Saturn, or fifth time or dozenth time I've seen Jupiter through my telescope. It honestly
still amazes me. Every time I look at it, I never get bored of looking at any of the planets because they are just so spectacular.
Goosebumps. You just gave me goosebumps.
There you go. See? It was only 5 minutes in, you already got goosebumps. This is going to be great.
Last summer, we took my girlfriend's family to Vermont, and we brought the telescope.
Sure.
And college kids never, her brother's a college kid and engineer, and so he's interested in all the mechanics and stuff, but he's never looked through a telescope at the planets.
Sure.
I showed him Jupiter. He's like, what? Like seeing the orange and the white stripes, and then seeing the moons. It's like, what? And then out of, we're in Vermont on top of a mountain, so there's like a bunch of trees and stuff, and we had to wait for Saturn to come into our line of sight. And I was like, okay, here comes Saturn. He's seen Saturn just like I think he stopped breathing for 5 seconds. He's like, that, it's literally breathtaking. Like, you can't get sick of hearing people react to that.
And I love that it's going to amaze the 5-year-old and the 16-year-old and the 50-year-old and the 100-year-old. It doesn't matter who you are or how old you are, that same reaction I get from every person is just, wow, that's really it? And I'm like, yeah, that's really a whole other planet out there.
I think it's one of those things when the older you are, the question that hit me when I first looked at it a few years ago, and now when I show it to friends and family, make them look through the telescope, the question, the reaction is, I can't believe I've been alive for 30 years, 40 years, and I've never looked at this.
Yeah.
How come nobody ever showed me this?
Right.
Did you, now you are in education, of course.
Sure.
But where was this in elementary school? Where's an astronomy class in elementary school? Did you have it? You're obviously younger than me.
No, I didn't, though. That's what's amazing is I remember it must have been like 9th grade when I took earth science, and it was just, a couple weeks of astronomy, no big deal. And I remember I had a telescope. I was like 9 or 10. And I hated it because it was one of those cheap telescopes that you couldn't actually point to anything, and I couldn't even find the moon with it. And I was like, we threw it away, donated it, whatever. So I had the worst astronomy experience as a child, but I still had this passion and desire to learn more. And it honestly wasn't until college that I had the chance to really learn what astronomy was about. And I want to change that for people, because I think, as you said, if they learn it earlier, or if they get intrigued as a young child, we can keep that scientific interest all the way through middle and high school, and just keep them going.
I feel like we forget to remember that we're supposed to care about that stuff.
Yeah.
Like when I started reading again several years ago about this, I'm like, I forgot how important all of this was. And I think that's like because in school, like you said, you kind of get a little touch of it. Like, these are the planets, and I went to school when Pluto was still a planet.
Right, so there was 9.
Yeah, like these are the planets, but there was never really that much. There was no depth beyond that. It was like, this is our solar system. These are our planets. This is our galaxy.
Right.
We all go around the sun. all right, let's talk.
Yeah.
Let's recess.
Well,
and I'm like, what?
And part of that we found is that it's an intimidating subject for teachers to teach because the teachers are our age or older and they haven't had the experience, just as we said. So they don't know how to teach any more than the planets, which is usually all they know themselves. And then you get the quick kids that start asking about galaxies and black holes, and the teachers are like, I don't know. So we're trying at the observatory to also teach the teachers so that they can share that passion with their students and answer their questions and, you know, continue to get them excited about it.
That's why I think it's someone like you so valuable, because it is such a hard thing to teach, because it's a hard thing to learn.
Oh, yeah.
And so you're already dealing with that. The type of people who generally learn this kind of stuff are the science, the introverted types, right?
Yeah,
the people that are like, no, I don't really want... I chose this so I don't have to talk to people, right? Like, this is what I love.
Yeah.
I want to just read books and know this stuff and figure things out. So it's rare when you have somebody who's friendly and wants to teach and understands the material. Like, it's very unusual, like alluded to Neil deGrasse Tyson earlier. Like, he's on top of the mountain, and it's just a perfect example of like, okay, a smart person who wants to communicate this and gets excited. Because a normal teacher, to your point, one, you know, they might not be science, like they won't get into teaching because they like just teaching and not necessarily just astronomy and sciencey stuff.
Right.
I had some great science teachers, but yeah, they weren't like very outgoing and like making it fun.
Exactly.
They were just like, this is it.
It's a big problem. And I mean, I appreciate you noticing what I'm trying to do, and I'm really happy that people are being intrigued by it, because we need more people that can communicate. I think that's our biggest problem with all of the issues in the world today, especially those related to science, is that nobody who knows what's going on is good at communicating it back. So people don't understand a lot of the sciences, and that's where a lot of the political drama starts, because they haven't been explained, they haven't been taught the science properly, and the scientists that are doing it are really lousy at communicating back to the public, you know, what are the results and what do we know and what are we still curious about and how does this fit into your everyday life? So just by taking astronomy and doing one small piece of the science, hopefully I can show people that it is an accessible subject and that, you know, I can be that person they can call up on the phone and say, hey, I saw this in the sky, you know, what is it? And people do that, and it's really, really fun for me.
This is like a 24-hour thing for you then. If people...
You know, it feels like it sometimes, you know. A lot of times people will call and leave a message on my phone at work at like 10 o'clock at night, and they're like, I'm outside right now, and I'm looking at something in the sky, and this is what it looks like. Do you know what it is? And then I call them back the next day, and I'm like, well, it's probably Mars, or, you know, whatever. And they're like, I'm going to go back outside tonight and double check and see if it's there. So I get calls like that all the time, and I'm so happy that people think of us and think of me as that person they can go to answer those questions.
Well, I seek people like you out.
Right.
Because it gets a little... I don't know if I'm so much frustrated anymore as I just kind of accept it. Is that just talking to normal, like we were in Pennsylvania this past weekend and talking to friends and family at a picnic that I hadn't seen in a while, and we're all taking a group family picture and everybody's like cheese or whatever, that whole thing, and I'm like, right above us, like as we're facing this direction taking the picture, Jupiter is just blown up in the air, and it's the only thing in the sky, right? Like at that time it's the brightest thing. And I'm like, hey, everyone, look, it's Jupiter. One person looked and went, no questions, there was 15 of us there.
Unimpressed.
And I was like, is no one impressed by, there's a planet, like, was it 1,000 times bigger than Earth, whatever it is. Huge. It's massive, and we can see that. Like, that's insane that we can all see. Nobody has questions. And then I was talking to another, my uncle who was retiring, trying to figure out what he wants to do in retirement and talk about reading books and doing all this and that. And I'm just going to like, well, maybe you're not reading the right book. Like, and I start going to a list of like topics that he might be interested in. And I'm like, what about fishing? What about the, military? What about history and this? No, okay, a little bit. And then I said, how about astronomy? And he went, like, made a face. Like, no.
What?
And
Aww.
Dude, like, I can't imagine what your heart might have done. Mine broke.
Yeah,
Mine broke like just a little bit, like, oh, like I had to walk away and end the conversation. I was like, dude, you just hurt me so much. So to hear someone do that, like, just totally dismiss it, I'm like, guys, there's planets everywhere. I know, there's crazy stuff going on. It's all out there. Yeah. Like, think about this.
I know.
So I just think, like, you're not going to hit everyone, of course. Just, because we have, and you have, like, you mentioned we tend to politicize things somehow, but this is like, this is all of us. We all get to share this, and it's like, dude, like, this is everything.
Yeah.
I can't believe there'd be anybody resistant to the Space Force idea. Just because Donald Trump suggested it. It's like, no, we're against everything. I just fantasize about the things, like how many problems that we're going to have to solve, right? Mm-hmm. And what happens when there's crazy difficult problems to solve, saying we're creating a Space Force. Okay, what does that look like? What's the goals and all this?
Sure.
And then you got to we have all these brand new problems to solve, which means you get all these really smart people together and they figure out how to solve that problem. And we invent new things that affect the whole world. And it's like, oh, there's a big picture here.
Yeah. Well, that's exactly what happened, back in the 60s and 70s during the Apollo era and the moon landings. It was, a lot of people were saying, well, why are we doing this, right? Why are we even bothering to send people to the moon? What's the purpose? And while it's, exciting and it's scientifically interesting, so much technology and engineering and just everything came out of that time frame, and we use it today. The development of the satellites. We wouldn't have TV or phone or anything had we not created satellites during that time frame that are now, thousands of them are orbiting Earth, and just all of the technology that comes out of that is just amazing. And you don't always think about it like that, but down the road, especially with this idea of people looking to go to Mars now, just going to Mars, is there a point for that? Well, maybe not, but all of the stuff that's going to come out of that, whether it's through a Space Force or who knows what's going to happen, it's going to benefit us. Somehow it's going to benefit us all.
Yeah, and movies like The Martian with Matt Damon, right? Yeah, Matt Damon. Just that idea of him planting.
Yes.
Creating, was it bioengineering, whatever we call that?
Yeah.
By terraforming. Mm-hmm. Creating things that can grow on another planet.
Right.
That alone, if we can figure out how to make Mars green.
Yeah, exactly.
What are we going to be able to do to Earth to make Earth, heal Earth, make Earth more awesome? Because Earth is already ready to go. It's the best planet out there, right?
Yeah.
But so if we could find a way to make something that sounds completely impossible happen on a place like Mars, what are we going to be able to accomplish on Earth?
Exactly.
There's
Everything
no limit.
always rolls back to us, And to answer a question about whether or not you can grow potatoes on Mars, they actually did an experiment to see if this could happen. They sent up a CubeSat, a little small satellite that's orbiting the Earth, and they put pretend Martian soil and potatoes in there. Potatoes totally grew. So we could actually do what the Martian did.
Wait, what?
And they can actually, most likely, you can't say for 100%, but you could most likely grow potatoes and certain other vegetables on the surface of Mars. So if we do send people there, it's a possibility that we could start growing our own food.
Wow,
so it's legit. It's already started. Just a movie. The reason they did that is because the movie said they could, and they were like, no, we got to see if we could actually do this. So they sent up the satellites, and turns out it'll probably work.
Wow.
Yeah.
And that's incredible how things would work like that. Just an idea, just a fantasy.
Right.
A fantasy of, sure, there's a guy on Mars by himself and he has to learn to grow food. Sure, sounds like, that's not going to happen, right? But then these people are like, well, let's see if we can.
Yeah. Well, look, Star Trek is always the example people go back to, right? If you watch Star Trek from the, 60s, 70s, whenever it started, a lot of the stuff that they had then was projections into the future. And look what we have now. We have, cell phones, which were very much like their communicators, and everything's a digital computer, and, all of that stuff. They often look back at those types of things and say, that gave somebody the idea. And it might have taken 50 years, but that idea is now a reality. And somebody just randomly dreamt it up. They didn't have the ability to make 90% of the stuff we have today back in the 70s, but now we do.
Yeah, and we're progressing so fast. Mm-hmm. Thanks to the prior progression, say with the internet and our cell phones, is that we're connecting and communicating so easily, so rapidly.
Ideas.
Like this conversation here. If I do a better job of promoting, several hundred people should listen to it. And it's going to plant this idea in someone's head. Mm-hmm. They're like, oh. And then maybe they'll talk to someone else. And the web grows. And then the more people you get involved, the more smart people are involved.
And it just takes one person. You just have to inspire one person's curiosity. And who knows what that one person can do.
Dude, that's basically your job, right?
Right, it's just inspire individual people, right?
You're almost the tip of the spear. Are you primarily dealing with kids, right? It being a kids museum.
Nowadays we do literally everything. I do work with a lot of children, but we have specific adult programs, and we have programs for 20-somethings now and teenagers. So we're trying to cover everybody, but the museum sees mostly kids.
Now, do you find most parents, I know most people my age or older don't know anything.
Sure.
But I feel like I don't know if my parents are like, hey, you shouldn't go that route. Like it's a fantasy. Don't
Right.
like. But it was never talked about, and teachers never talked about it again. I kind of got the sense grown. I remember thinking like, this is so fascinating the first time I heard about this, and then no teachers ever brought it up again. My parents never brought it up again. No adults ever brought it up again. It was never like, it was always just in a sci-fi kind of fun thing, and like fake cartoons like outer space, the planets, Mars, invade. It was never like a serious thing. I just thought, oh, this is it's insignificant because nobody takes it seriously.
Right.
Do you think that's kind of changing? Like, are we starting to take it a little bit seriously?
I think we are now. You know, I very rarely come across the parent that's like dragging their kids away saying, no, you can't be a scientist. An astronomer is a stupid job, you know. People are interested, and I think we fascinate the parents just as much as we fascinate the kids sometimes, and I think that they would love to see their children pursue that. And they often don't know what being an astronomer really means. I mean, there's many paths you can take as an astronomer. But, yeah, I mean, the kids can do anything nowadays, and the parents seem very supportive. And I think a lot of it comes from sci-fi, and a lot of it comes from the interest that NASA is trying to instill in everybody that we have these telescopes, we have these satellites, we have all this cool stuff, and you should pay attention to it.
Did they create the position of outreach astronomer for you? Or was that something that already existed? Because I never heard of outreach astronomer.
Sure,
and I'm
sure.
that's a majority, if I could think of the top 10 coolest people with the coolest jobs that I know, just going by title. I'm like, hey, I'm going to talk today with Valerie Rapson, the outreach astronomer.
Nice.
That's one of the coolest titles I
like
can think
that.
of
I feel
I've ever
honored.
met. I think it's so awesome because it's like you just reference the path that an astronomer could take. I would never have thought.
Sure. And a lot of people don't. So like they created the outreach astronomer position because they wanted a professional astronomer, somebody with a PhD, a strong amount of education in astronomy, but they also wanted them to be a communicator. They wanted them to be the face of the observatory, to reach out to the public, to work with the kids. And that's where the outreach in front of astronomer really comes from. If you say astronomer, you think, you know, the old guy sitting at a telescope doing his data reduction on the computer, you know, that's what you think of as a professional astronomer. So outreach astronomer really means education. You're going to take all that astronomy knowledge and you're going to spread it out there. You're going to instill it all in everybody else and get them just as excited as you are about the astronomy education. That's exactly what I want to do. I mean, I want to be the next Neil deGrasse Tyson. So if he's listening, man, I'm coming for his job when he retires. I want to do what he does. It's just amazing.
But do it better. Do your own spin.
Oh yeah, exactly.
Like,
I don't want to be him, I guess, but I just want to do what he does, as you said, in my own way. You know, reach out there and just.
Because for sure you're better at things that he's awful at. I'm sure of it.
Well, you know, we all have our different touches, right? He always said he wanted to be like Carl Sagan, and he's not Carl Sagan, but he does his own thing and makes as many connections and communicates with the public just as well as Carl Sagan did in his own way, and hopefully I can do that someday too.
Do you have a book in your head?
A book that I want to write? Not yet.
Now, I mean, there's obvious angles here.
Yeah.
There's obvious angles, you being such a good communicator and dealing with kids. And yeah, you need to get some, like miSci to finance publish a book of yours. For sure.
Yeah.
Like, for sure. You want, that's the next big step.
Yeah, maybe I'll write
to sell your book. You have
astronomy book.
Dude, we could talk about this later. You should. You totally should. You have the structure already there. You have a place to sell your book. They're like,
That's true.
Put that on the shelf when I'm walking into the miSci and paying my admission fee, which I think my year thing just expired. But yeah, when I have to, I have to go in again. But if your book is sitting right there, our outreach astronomer Valerie Rapson wrote this book, dude,
that would be fun. I think we could definitely use something in the middle, like for that teenage realm, because there's a lot of astronomy books for the adults that are like, this is what you can see in the sky, and there's a lot of textbooks for the college level, and then there's a lot of children's books, you know, with the picture books of fantasy and the stars and all of that, but something in the middle for that kid who is just interested enough where, you know, the teachers and the parents can't help anymore, but they're not ready for Astro 101 at the college level. I think that'd be a fun book to write.
Good. I want to be part of it. I'll sketch.
All right. That's good because I can't draw at all. So I'll write the content and I'll be like, can you doodle me this picture here?
Can I do the audiobook too?
That would be great.
All right. We're on to something, Valerie. We're on.
Let's do
writing it down in my brain. co-authoring an
That would be
astronomy
awesome.
book.
I love it.
That's bucket list
Great
type
idea.
stuff.
Yeah.
Where's your favorite place to go see stars? Do you go camping?
I don't go camping as much as I'd like, but I have gone camping before, and just anywhere dark is great. You know, the amateur astronomer will look at the cities and be like, oh, you can't see anything there. And that's totally not true. I don't want people to think that because they maybe live in Troy or Schenectady or Albany that they can't see anything. You can see so much out there. And, you know, going up to the Adirondacks is way better. You can see a lot more stars. But, I don't know. I don't mind being kind of near the light pollution and just enjoying anything that's up there.
It makes the like I said, Jupiter, and it makes the planets really stand. Just
Yeah,
watch during
it really
the sunset.
does.
Look at Venus. Look at Jupiter. Look at Mars. You
And
can
you
see
can-
You can see Mars. I haven't seen Mars in a while.
Yeah, no, Mars is still up there.
Okay,
But
it's still up there.
It's still up there. You can still see it. But, you know, it's easier in the city to do astronomy in some sense because if you start with the constellations, you can find them. If you go to the Adirondacks camping, there's a hell of a lot more stars up there. It's really hard to see the constellations. So if you're just getting started, it's almost better to be somewhere like Troy where you're finding Orion and you're finding the different constellations. Then your next step is to go camping, go to the park, and, you know, try and see if you can find them again when there's a few thousand more up there.
To your point, just last night I walk outside to walk my dog, his nighttime walk, and so it's like 9:30 or so, just as last pee of the night for a little Muncie. And I look up, and it's easy to see Polaris. It's really easy to see Polaris,
Right.
and then I see the Big Dipper. I'm like,
Yeah,
boom,
so you know. Done.
like, and is that why they're so common? And like everybody knows those ones because living in the city, like
think
those are the
so.
only ones you can see.
Right, that's what you see. And with the dippers, of course, they're in the north. So no matter what time of year, you can always see the Big and Little Dipper because they just spin around the North Star. They never rise and set. So they're visible more throughout the year, so I think people notice them. And like you said, they're easy to spot, too. The convenient shape.
It's one of my favorite things to do bright and early. Like when I was up the other day at 5:30 in the morning, my back porch is where the sun rises and the sun sets in the front.
Sure.
Is to find the North Star, Polaris,
Polaris, yep.
right? And just imagine, like, knowing where the sun is coming from, I can imagine which way the Earth
Yeah.
is turning. I'm like, we're turning right now.
Right.
Oh my God,
Right.
now the sun's going away. And now it's going away, and oh my God, we're still turning, and because you can easily understand why people for thousands and thousands of years thought the sun went around us.
Oh, yeah.
But
That
if
makes
you-
total sense based on what you see.
But if you know where the North Star is, and you just know where the sun is rising from, and you could just imagine, like, okay, the sun is coming up here. There's the North Star. I must be turning this way right now.
Yeah.
It's like.
It's hard to think about.
It's earth shaking.
Yeah,
like
literally.
you feel, like literally, you're like, I'm moving
Yeah.
right now, 800 something miles an hour, whatever it is at this time of the.
ridiculously fast.
It's like, this is insane. It's a way to like, okay, this is a way to start my day. And like, whoa, that's intense. And I'll do it at nighttime too.
Right.
Like even when I was out with the dog last night, I was
Yeah.
like, we're spinning so fast right now.
Yeah.
And we're on like our side. It feels like we're on our side. Like you see the.
Yeah, because of where the North Star is and our latitude, it feels like we're sideways, yeah.
Yeah.
You would enjoy taking star trail pictures. Have you ever done that before?
No.
Where you put a camera on a tripod and you have to have the ability to leave the shutter open for a long time. But if you just leave a Canon camera out there and it'll take pictures for like a half an hour, what you get are the little lines instead of the dots because the stars have moved and you can see them rotating around the North Star. I think you'd have fun.
I have
taking
fun with
kind
all of
pictures
this.
Like that. Yeah.
When my girlfriend and I went camping, we're gonna go camping this weekend too because it's gonna be incredible this weekend.
Nice.
We went camping, I don't know, a month or two ago was the last time. We haven't gone camping recently. Ooh, I don't like that. But life stuff to do gets in the way of outer space.
It happens.
But when we went camping a couple months ago, woke up 3 a.m, walk outside the tent, and we're out there for like 4 minutes, 5 minutes,
Yeah.
and just shooting star after shooting star after shooting star. It might have been during the Perseids.
Yeah, the Perseid
right?
meteor shower.
Yeah, it was
Must
just
have been.
boom, 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 boom.
Yeah.
It's so just it freaks with your mind. Like all of this
Right.
is so mind bending that I don't know how anybody could just see something the world the same anymore.
Sure.
Like you got to see like, oh whoa, there's a lot going on here, which is what I kind of was hoping with the solar eclipse last year. It's like, I hope enough people get really excited about this that they lose their mind. They're like, oh, all these trivial things we're talking about are boring.
Right.
This is cool.
This is cool, and this is what we should be spending money on and paying attention to.
Right.
You know, and I think it really did help. I mean, I don't really feel like the hype is there at the same level as it was last summer, but it got people excited, and I think more people are paying attention, and people are looking forward to 2024 when the eclipse is going to be right near us. So
Ooh.
Can't wait for that. Although it is April, which April here, it could be, sunny and gorgeous, or there could be 2 feet of snow on the ground.
Right.
You just really don't know.
Yeah, because it hits a little bit more north of here, too. Like, through St. Lawrence County, where I used to live. And April up there can be really gnarly. Like, it snows in May. Yeah. I've seen snow in June, actually, up there. It's weird. I
don't mind snow, but I mean, by June, I just need a break.
Yeah, okay. I love winter. I love snow. But yeah, it's like, guys, really? It's May. It's June.
Yeah.
I want to go outside and play now.
Seriously.
Yeah, but anticipating that, there's going to be a lot of people on board for that. And you referenced the political stuff, and I mentioned Space Force.
Sure.
The only part that kind of irritates me about Space Force is how it has to be sold. Like, it has to be sold as part of the military, right? Like, this is a military, but you can't just sell it. This is educational. Like, I want that sales job. Like, hey, American people, this is educational.
Yeah. And I haven't learned too much about the Space Force yet. I don't know how much, they've really put out there, which is anything. But, I think that's what it's kind of turning into is, take some of what the Air Force does related to space, especially related to protection, and, put that as a different branch. I don't know how much education there is because the last federal budget, with the last administration, they cut the education budget of NASA completely out. Not just cut it down, they got rid of the Department of Education within NASA. So it really made me sad to see that they didn't seem to value sharing the information and teaching people about what they were doing. They just focused all their money towards the actual science and engineering, which is great too, but you got to tell people what you're doing if you want them to keep giving their money towards it,
Right.
So I'll be intrigued to see how the Space Force is spun. If it really turns out to be purely a military and protection-based thing where we build satellites to monitor things and whatnot, or if it actually does start to encompass NASA in some way and involve the science and education. I'm excited to see what exactly it is.
Yeah, see, that's why I'm all for it, because in my head, it's exactly that. It's educational.
I hope so, and I don't know, though, so we gotta wait and see what exactly is gonna happen.
See, I remember there were when during the presidential elections in 2016, there were 4 to 7 things that I heard Trump say that I'm like, yeah, man, keep talking about that. That's good.
Yeah.
Stop talking about all the other nonsense, that silliness. Talk about that. And one of the things he said was something, he kind of got poetic for him. He was just like, and we're going to go back to space and discover the mysteries of the world or something like that.
Right.
And I was like, what?
Yeah.
Where's this coming from, man?
I know.
Okay, talk more. Tell me, what does that mean?
Yeah.
And then, whisper. Nobody ever talks about that because it's, not a headline. But I'm like, that's an important thing.
Yeah.
That's a very important thing. And I wasn't expecting him to say it. And I'm like, that's a very important thing. And there's no follow-up. And then I just thought it was just dead in the water until, a few months ago, that, we're going to have a Space Force going on. And I'm like,
yeah, well, so there was also this new thing. He has a Moon to Mars directive, they call it. This came out late last year. And the idea is that he wants to privatize sending people to the space station. He wants to privatize basically low Earth orbit. So the satellites, the space station, all of that. Take that away from NASA and the taxpayers and focus more on sending robotics to the moon and then getting more robotics and people to Mars. So he's working on that, and I know there's been, a lot of debate and drama about, some of the things that he's done that people aren't happy about, but he's been very kind to NASA. And I think NASA even got a slightly higher budget than they requested. So there really is, in this administration, a positive look towards NASA and space in general, which is really exciting for the astronomers.
It's unexpected. And if you just read headlines, you would think, anti-science, anti-all that.
Sure.
It's like, no. Really look at some of these real policies, not the rhetoric, the rhetoric. It's like look at some of these policies. To your point, it's like, hey, here's some more money. It's hard to picture of a reason why a 74-year-old dude would be caring about a businessman just wants to be a millionaire, billionaire forever. It's money, money, money. How that person could care about outer space. And then I just think, I'm like, oh, he was just completely ignored as a kid. This is my little fantasy. I like trying to figure people out.
Right,
Because
right.
it doesn't add up, right? Like,
Sure.
it doesn't add up why a guy who's just so obsessed with me, billionaires, millionaires, I'm number one.
Right.
And he's a really old dude, and he's also into outer space. I'm like, did he just miss something in his childhood? Did, like, did his, no relationship with his dad or anything, and like nobody ever taught him like to be fun, and now he's just like, no, was this always an interest that he never cultivated because his dad, his family said, no, you're gonna be going to Ivy League school, you're gonna be a millionaire, you're gonna run this, you're a businessman.
Sure.
And then now he's like, I'm gonna be president one day, and I'm gonna go to outer space. Like, that's kind of the game I'm playing with.
Right in your head.
Like, this seems like this is important to him, because some of the stuff that stands out for me. And to your point, it's like, when the previous administration like started cutting this stuff out, I'm like, why are we cutting NASA's budget? Like, please explain that to me.
Yeah.
I don't understand. And because it's not like we're done.
No. And just so people understand, like, NASA's budget is 0.5% of the total federal budget. 0.5%, right? I think this year it was just under $20 billion or something. Which, I mean, it's a lot of money, but if you think of it in the grand scheme of things and all the money we put towards other things, it's a very, very tiny amount, and we're doing so much good with it. Like, it's all good, and the technology is benefiting the everyday person, so you would think, why? Why would they want to cut it?
But what the effect of that of those kinds of cuts, though, is you get someone like Elon Musk, who's like, okay, you guys aren't going to do it. One of my favorite things.
I'm going to do it.
That's my favorite.
That is really awesome.
I mean, you could just look at his whole life, his whole body of work, his whole life, and that's inspiration enough. But the one thing I always think of him saying, my favorite thought. Of course, I mess up quotes all the time because I mess up words.
Okay.
But the idea is, he's like, I remember hearing about all this talk for decades. Oh, someday we're going to go to Mars. Someday we're going to have self-driving cars.
Sure.
Someday we're going to this, someday that. And he's like, I've been waiting for decades and looking around, and no one's doing it. No, I'm looking around, and no one's actually doing it. But we're still saying, oh, someday we're going to go to Mars. Someday go. And he's just like, so I decided I had to be the one to go do it.
Right.
And I love that. That's so, like, fine.
It is
if
cool.
somebody's got to do it, and you're just waiting for someone to do this, is going to happen. And then when you start sucking the money out of a place like NASA, be like, okay, government's not going to do it. The wealthiest country in the world, the rest of the world's looking at us. Like, okay, what's the United States going to do? They're the ones for it, right?
Yeah.
They're the ones capable of this, and we're not doing it. It's not going to get done.
Right.
And so a guy like Elon Musk steps in and is like, okay, I got the money. I'm crazy. I'm a super genius, and I can make this work. And I love that he's been delivering the last several years. He's been the sole supplier almost.
The Falcon rockets, yeah. I mean, you're exactly right. I think it did kind of kickstart a whole bunch of people to really think about space and what they could do with their money in building these rockets. So, SpaceX has the Falcons, the Falcon Heavies, and what they've done is they've made reusable rockets and rocket boosters to make it more efficient and cheaper. So instead of just destroying the rocket when we're done using it, parts of it come back to Earth and we refurbish and we reuse it. Cuts millions and millions of dollars out of the cost of rocketry. So that not only helps NASA, but it helps SpaceX and the taxpayers as well. It's a really great thing that has happened. So it's not all bad that NASA's budget was cut, but I really wish they'd give some money back to education.
Right.
That's the part that irks me the most. It's like,
because that's all we got. We're nothing without our education.
Exactly. And the other space agencies across the world, they do such a good job with facilitating the information and sharing it with the public. And I wish NASA would jump on the bandwagon and realize how important it is to share what you're doing. They try in some aspects, but it needs to be a cohesive effort from one place within NASA. When each individual mission is doing their own outreach and education, it gets jumbled and it just turns into a complicated mess. And then half of my time is spent telling people where the websites are and how to get the information. If it was in one spot and just a conceited effort, that would be really ideal.
I doubt that, because one, it's the government. It's the government. But then also with NASA, like, we never really know who's in charge. Of course, you're going to have I'm the director of NASA, and blah, blah, blah.
Right.
But we know for sure. The military colonel steps in, general steps in. It's
Yeah.
like, nope, what you're doing now, I'm in charge. You're not going to tell people about this thing. You're not going to. It's unlike Elon Musk, who with these Falcon rockets, he's showing us that they can land a rocket that was in outer space. Or the booster. Does it get to outer space and then come back down? Or
Usually,
is it just get to the...
it depends. Some of them are designed to go technically into space high enough to be space. Others come back a little earlier. It depends on what piece of the rocket.
It lands!
I know.
You've seen the videos,
cool.
right? Like, I've seen those videos repeatedly. And I saw plenty of... I don't know if they've had one that's failed recently, but I remember the early on for, it took them a while. Like, they would crash land. They wouldn't land. But they kept going. They kept going. And that's private money they're burning.
Yeah.
That's like Elon Musk's and his investors' money.
Right.
And they're like, no, we're going to get this right. We're so close.
Yeah.
And then when they do it, it's the
It's
like,
amazing.
it trips...
It's so amazing.
That rocket... comes back down and lands on a platform.
The ones recently, did you see the two that just come down simultaneously together? I was like, I could never imagine that happening. It just looked like a cartoon, It didn't look real, but it was fantastic.
One person thought of that. Right. Like, hey, we gotta land these things. How about this? And then he was probably laughed at.
I'm sure. I want to be in the room with the engineers that just... What do you want to do?
It was probably just complete silence.
I'm sure.
Like, hey guys, we should probably just land these again. We get to reuse them.
What do you think about recycling the rockets?
What? So now, but that was to our point about Space Force and solving new problems and new technology. They created a problem to solve. Well, not created, but they created a solution to a problem, and they had to figure out that solution.
Right.
So they figured out how to land a rocket. Now, who knows? I don't know the technology used for that. Obviously, I don't have a shred of knowledge about the ability to do that. Like, where do you even start? I have no idea. But I gotta assume that technology transfers over to maybe his self-driving cars. Like, if you could land a rocket on a platform in the water, like, I'm pretty sure we could figure out a car can figure out how to parallel park or stop at a stop sign and know whose turn is to go.
Right.
Which that is a question. If you're at a 4-way stop sign, how do they're all self-driving cars?
Yeah.
How do you figure?
I don't know.
There's so much thinking involved in that.
Right.
But that's definitely those self-driving car. Everyone's doing self-driving cars now. But those people in those rooms are answering those questions.
Right.
What would you think? What would your answer be?
When Google goes first?
4 cars.
So
all coming to a 4-way stop. They're all self-driving Teslas. Or self-driving anything.
What I think you would have to get with the technology is, so it's watching every car, right? And to us as humans, we can only perceive a certain amount of time, but I bet the computer could tell, like, literally exactly which one stopped first, and it would have an order in mind and know exactly which car would have to go based on distance.
Do you think...
I bet that's how it would
that's
work.
Probably...
Because you can get down to, like, minute details about exactly how far you are from the stop sign and when you stopped.
I was
better
thinking,
than a human.
I think you're totally right. And what you just said made me realize I was thinking about it incorrectly. I was kind of thinking each self-driving car being independent have its own little internal system, but they're probably all networked up, right? Like they're all probably all talking to each other.
Sure.
Like, okay, I'm going to go, and then you're going to go, car 1's going to go, and then 2's going to go. Then they all just agree, and then they go. I'm sure they're all networked up and they're talking to each other all the time. That's probably the way it goes. That's the only way it could go. You can't have, like, all these individual...
It would have to be, right? But what if they're not all Teslas? What if they're different brands? Do the brands talk to each other? I don't know. See, this is where we need the engineers. I'm not an engineer, but
we can fantasize. Because then it goes down to the GPS satellites, right? Mm-hmm. Which I recently saw something on the history of the GPS satellites. I love that. That's so fascinating. Yeah. It's so fascinating how they use Einstein's equation.
Yes,
that was like the first real test of his equation in outer space, right?
Yeah, one of them. Yeah, definitely. It's like you have to have relativity. Relativity has to be a thing, or your GPS signal is going to be off. I think in like 6 minutes or something. Like
it was
a ridiculously small amount of time. You'd be wrong. About
it said it was a 10-kilometer difference per day.
Oh yeah.
So basically, it would be worthless. Yeah. From the moment you. Yeah, probably 5 minutes or so. It would be completely worthless.
Yeah.
Yeah. Yeah, it's that kind of stuff. It's like, we had theories, and then we had a problem. And of course, that started with the military, the GPS.
Sure.
And it wasn't until the late 70s or early 80s that they opened it up to the public. I don't know if you remember, too, this is what I remember I remember hearing about it, but I really wasn't sure what it meant until I watched this documentary again. But in 2000, so when they first allowed GPS to go to the public, they would only allow it within an accuracy of I think 50 meters.
Oh,
so
really?
Because they didn't want too precise of directions or too precise of pinpointing, because they thought, it was all military thinking.
Sure.
So they didn't want to go into the wrong hands. And then in 2000, Bill Clinton, that administration's like, nah, we got to let everyone have this now. Like, they got to get it down to, now I think we're within 5 meters accuracy or something like that. Like, it's crazy. It's really, really, and there's 26 satellites of the U.S., but Japan, this is something cool. I'm going off on a weird little tangent.
It's okay.
But the funnest thing I learned from that is Japan has its own 2 GPS satellites, because like Tokyo, they have these big, massive, tall buildings, and the regular GPS signal can't get through.
Really?
So they use all of the United States one that the whole world, most of the world gets to use.
Yeah.
But Japan also has their own 2 satellites up there that allow you to get accurate within the canyons of these cities, in between these buildings.
Yeah, that's cool. I never really thought about that, but you're exactly right. That has to be the way it works.
Right. And so they have to figure it that that one of these satellites is above, I guess, Tokyo, above the island at all times while they're going around. I'm like,
sure,
I want to know how they figured this out.
Right.
Who thought of this? It's all because people are looking at outer space, though, is what this all boils down to.
Yeah.
Right?
Yeah,
like,
people are
curiosity.
thinking about it. They're intrigued, and like, that's why we work with the kids so much, is you never know which one of the kids you see is going to be the next Einstein. And had Einstein never been inspired to do the science that he did, we wouldn't be here today with the technology that we have, So we want to inspire every person that we can, because you never know what's rattling around in their brains and what's going to come next.
You never know. And
really
that's the
don't.
thing. Like, even Einstein wasn't seen to be an Einstein in his day. Like, he was just, oh, that's a normal dude, blah, blah, blah. He's kind of sharp. He shows up on time.
Right.
He's really good with details.
Weird ideas about how the universe works,
He plays the violin in his spare time.
Right.
But he works in a patent office, doesn't really bother anyone, has a wife and a kid. Everything's fine. And then, he turns out in his spare time.
Right.
His spare time.
Total genius. Yeah, I know.
Yeah, you might have met, like,
crazy.
these people are real people, to your point. Like,
Mm-hmm.
you can affect these people and change the course of history. You can literally change the course of history by sparking a child's mind.
Maybe I already have. We'll have to wait and see.
That's the fun thing, right?
Right.
Well, that's a real thing, right? When people come back and they visit their old teachers, and they reference, like, you know, like my 5th grade teacher, my 3rd grade teacher, and those teacher had no idea they affected that person.
Exactly.
And then they get that letter 10 years later, 20 years later, and they're like, oh, it's you.
Right.
And they're like, what? Wow.
Yeah.
That's got to be kind of frustrating as a teacher, though. To be like, you might hold... Do you think there's, like, how many 60, 70, 80-year-old teachers are just sitting around like, come on, phone, ring, somebody use me in their Nobel Prize acceptance speech. Come on, someone. I got to know I mattered.
Right.
But most of them don't. But you must have had cool teachers, though.
Oh, I totally did. Yeah. I remember my chemistry teachers back in high school. They were female, and I think that was the first time that I had a female science teacher, like a hardcore science, not just your elementary school teachers, who most of them were female too, but just seeing that, I think, inspired me that I, as a woman, could be a scientist someday, whether it was as a teacher or as a professional astronomer or whatever. That, I think, is what really sparked it initially for me.
Yeah, see, I also had my best high school, or my best science teacher was also a woman in high school. But from my perspective, I don't know if it's just a guy's perspective or just my own unique individual perspective, I didn't see her as like a science teacher, and I didn't think that was weird. I just knew she was a smart person, a smart teacher, because I was surrounded by smart girls all the time.
Of course, we're all smart, right?
Yeah, and that's the thing. I've always continually outperformed in school by girls. Like, I never even seen, like, boys are smart or girls are dumb. I've never even seen that. And what girl... Like, I didn't know there were limitations in girls' minds. Like, so I'm sitting there like, this teacher is brilliant. This teacher's awesome. I love this. Oh, look at my classmates I'm in this science project with. They're really smart girls.
Sure.
But I didn't realize that that so many girls just felt like that was a thing.
Mm-hmm.
Like it was like, hey, I didn't realize women could do that. Mm-hmm. Like it never crossed my mind. So from my perspective, that was my best teacher. She was brilliant. One of my favorite projects was a mole project. You know, mole, like it's the
that number. It's
the number
the special number in chemistry,
volume
right?
volume. Yeah, and I made. Do you know the band Kiss?
Mm-hmm. Of course.
All right, so my mole project was the words "kiss" designed as the way "kiss" was, and it's supposed to, like most people, the really smart people. I have a problem with being creative; I can't help it.
Sure.
So, but the really smart, logical people made nice, like it's easy to calculate the mole just using like squares and rectangles and triangles and stuff that are easily to figure out their volume. I wanted to do the kiss sign exactly the way it was written. So it got these weird K with the bendy loop and the S. I spent so much time on that thing. And it was beautiful. Yeah. Like I spent and I was way wrong. And I spray paint. I used styrofoam and then I spray painted the styrofoam. Here's a lesson. Oh yeah. I mean, in case you don't know, if you spray paint styrofoam, it just like disintegrates. Like, so I went from a beautiful kiss mole that was way off because at some point I was like, hey, I can't accurately calculate this because I got like curves and bends and stuff in it. But it was beautiful. Like people were like, and then when I brought it into class and compared to everybody else's, there was no level of creativity, but they got their mole numbers exactly right. Right. But this teacher, I don't remember names, I remember people, and I remember her. She was so great. She loved it. She loved the effort I put into it, because I was up like way late at night and got up really early in the morning to try to finish that thing and try to make it look as pretty as I could. And she appreciated it. I was like, hey, these numbers are way off, but this is what I did. This was impossible for me to do. And she really appreciated it. I got a good grade on it. Sure. And I was like, she encouraged me. I felt like I had failed because I'm off. But I was trying to do something that was really, if I tried to do it right now, I'd be like, this is really hard. But I tried, and I loved her for that because she rewarded the effort. Yeah. And so for that, she's one of my favorite. Yeah, exactly. And I was like, oh, is this what science is? Yeah. And then unfortunately, I think that was my last science class. I mean it very unfortunately because I mean, I'm basically that's what we're doing right now.
The science, right?
You're doing science, so I'm re-upping that education.
There you go. See, it's science class right now.
But the whole that is I know I hear lots of girls say that. I got nieces that think the same thing too. Like, I'm a girl, I can study this. And I'm like, I didn't know there was resistance to it. Like, I didn't know a little girl saw the world that way. Yeah, and I don't know that I did as a young girl. I see a lot of young girls today that think they can't do things, but I don't know whether it was all of the female role models or my parents just being like, yeah, you can do anything you want. I never felt like there was a limitation. I think that's why I am where I am today, is that I just never saw any restrictions, which is great. But in retrospect, seeing what I was going through everybody else's minds and watching other young children, it's like I realize how many role models I had throughout the years that I didn't even realize were affecting me in that way until I look back now, and I'm like, that's why I had great female teachers and female mentors through college, and I got to teach a high school women's physics class when I was an undergrad, like all these things. And I'm like, I get it now. I get how I made it in life. It was because of all those experiences. And I can only hope to give those experiences to other people and show them too, to your point of the whole creativity thing. It's a lot of young women are really into the creativity, right? They're into art, they're into just creative things. And they think that science is all math and boring. They don't see that the two can overlap so easily. They're like, oh, I'm an artsy person. I like to do crafts. I don't like to do math. And while those are different things, they overlap so often. And we need to be able to show people that you can be both. You can merge the two together. You can do those cool things. You can build a kiss sign and calculate the angles and do whatever you want to do. You can do both. And that's a beautiful thought, because we know people, some of the greatest people in history were those people. Yes. Da Vinci, Newton, Einstein himself. Like I said, he played the violin.
How many scientists and musicians together are in the world? We just I think it was 2 years ago now, the Observatory provided a grant to a woman over, I believe she was in the UK. She's a professor, and she's doing a research project on William Herschel, a historic astronomer. And she's looking at the music that he wrote and how it may have influenced his astronomy, because you can see when he started to get into astronomy, there was a change in his music, apparently. And I'm not a music historian, so I don't really know. But that's what she's working on, is how does the creative side of a human being affect their scientific and mathematical side as well. And it turns out that they are more linked than anybody would ever have imagined.
Well, to your point, and that's beautiful, and I love that, and that gets me so excited thinking, like, those are real people walking around that are figuring that out. But to your point about how you reference Star Trek, like, the people that created Star Trek were super creative people. Like, these are just whimsical fantasies of outer space. Imagine this, imagine that, let's create the set like this, and they pew, 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 pew. And so all of that, so there's that creative side with some little accurate science in it, right? Like, there's some, but the science dudes and chicks that are watching that are like, okay, I see what they're saying here. All right, I'm not creative. I couldn't come up with that idea, but I'm going to take their ideas and see if I could really figure that out.
Exactly.
The potatoes floating around the planet right now.
Right.
Are they still out there? Or they ship them back down and check them out?
Well, there's cameras on the inside, so they were watching them grow. I imagine that it has come back, or maybe it burnt up in the atmosphere when it was done. I don't know for sure. I just recently read about the experiment because I was looking that stuff up. And
who did it? Was it what country?
Oh, it was somebody here. It was like a university. It was a college project. I'm blanking on exactly who and what it was.
College project?
Yeah,
what college has a rocket? Or do they use a balloon?
No. They actually, so anybody can build a CubeSat. A CubeSat by definition is usually like 10 centimeter by 10 centimeter box, and then you contract out with NASA or SpaceX or somebody to launch your CubeSat. So a lot of these rockets, like all the Falcon rockets that are going up with SpaceX, they're carrying hundreds of CubeSats from various colleges and random people who have paid $1,000 to have their CubeSat included on the rocket launch. So nowadays, literally anybody can launch something, and I'm sure there's restrictions, but you and I could build something right now and just have it launched into space.
Now, I feel like I've heard people just put their records or something in outer space, or just something. They're like, hey, I made this. I want my first book, whatever it is, to be in outer space. I'm the first person to put a Big Mac in outer space or something like that. Like, are people doing like cheesy things like that, or is it? Well, those wouldn't get priority, right?
No, those wouldn't get priority
unless they pay a lot of money to some rich person.
I think they have to be like real science experiments. If you're going to do a balloon, like you could launch a weather balloon up to technically to space with anything you want. I mean, as long as you get clearance to launch something that high, you can do whatever you want. People have done the little Lego figures, all sorts of random stuff.
And then what? There's like a little tracker on it, and you just find it.
Yeah, I mean, depending on how high it goes, it's either going to burn to shreds when it comes back through the atmosphere, or if it survives, then you put a GPS tracker on it, and sometimes you can go fetch it and find it.
I think you just gave us a second project. We're going to do your book.
We're going to write a book, and we're going to launch something into space.
Your book!
There we go, let's do it.
You don't tell me that wouldn't be the dopest thing you've ever done.
That would be amazing.
That would be like, honey, you're married, right? You're like,
yeah, almost.
You'd be like, honey, you know what I did at work today? Sent my book to outer space.
There we go. Legitimately. Like, we're all around the TV watching the launch and be like, my book is on the rocket ship. It's up there, man.
What did you do today? Oh, you didn't put your book in outer space?
No.
Okay. All right, my day was better.
Right, I'm going to put that on my resume. Launch book to space.
The first line.
Yeah, right.
Like, for real. That's a huge deal. So.
That would be amazing. You're giving me new dreams here today.
All right, we're brainstorming. I'm always looking for a collaborator.
There we go.
All right, good. So what kind of cool things are coming up at miSci? What do you got on the docket?
Well, our big thing, of course, is the new observatory. We've been open every Sunday from 1 to 2:30, and we've been doing solar observing. But next Thursday, September 13th, we're going to be open in the evenings. And we're going to be open every single Thursday throughout the entire year, as long as it's not, total snowstorm. For people to come, 6:30 to 8 o'clock. That's our big thing. So just show up, pay admission. The observatory is free with admission, and you can kind of come in and out all evening long, look at different stuff. That's what we're excited about. And our science festival is in 4 weeks now. We're doing it over Columbus Day weekend this year. We're shifting it forward. So it's 4 days of just wall-to-wall science, literally. We have partners from all over the capital region coming in, bringing cool science experiments. We've got stage shows, live animals, the telescope. It's a blast. Love, love, love the science festival.
Whoa. Live animals. What kind of live animals?
Yes. The people come and they bring snakes and other cool exotic animals. So let me tell you, last year at the Science Festival, we did, I had an infrared camera out because we were talking about the James Webb Space Telescope and how it was going to launch this year. But we won't get into that.
That's so that's like the biggest tease in my life, right? That's such a big tease because there's so much stuff that's going to see, but we have to wait.
Right, yeah. So anyway, we were talking about that, and we bought this cool infrared camera for people to walk in front of and, see themselves in the infrared so we could talk about what the telescope was going to do. And we happened to be positioned across from the live animals, of which he had a lot of reptiles. So I went over and I said, can I borrow a snake? And he gave me this giant python thing. And I walked it over to the infrared camera, and because they're cold-blooded, you could see the color difference, right? Because they have to lay under the lights and they're the same temperature as the surroundings, right? That's how they get their warmth. So you can see my body is really warm and the snake is like a totally different color because it's colder and it's trying to absorb my body heat. And it was just the coolest thing to see these reptiles,
Before I tell you how smart of an idea that is, was that your idea?
It was my idea.
That's a really smart idea to impress people, make them go, wow!
Right? It's like, here's the snake. Now go bring it in front of the infrared camera.
Wow, that's really
it was
really
really
neat.
Fun.
All right, so you mentioned Andromeda earlier, and I've seen really, really cool pictures of Andromeda through Hubble. Mm-hmm. How does it look through the telescope?
So it's not going to look like what you see online at all. I'm just going to be honest. If you look at it through our telescope, it's going to look like a little fuzzy cloud.
Okay.
And you're not necessarily, unless it's really clear, you're not going to see the spiral arms all that well. You really need to take pictures to see that. The Hubble images that you see are tons and tons of pictures stacked on top of one another in multi-different colors, and it's really, really detailed. So when you look at it from here, all of the starlight kind of blurs together, and it looks like a fuzzy, small cloud. But, you can tell that it's a galaxy. You can tell that it's different. It's not a nebula. It's definitely not a star. It's distinctly different. But it's not as impressive as Hubble, so I'll be honest with you.
All right. I just need to know that.
Yeah.
Because I don't want my expectations
right,
shattered.
Yeah. Well,
but they were low anyways, if I get to see it. Because one of my favorite... I don't know, it was Galileo, one of those dudes. He noticed just bare eyes. He's like, hey, there's a smudge up there. Yes. I don't know what it is. And isn't, I don't know if it was Italian or whatever, but nebula or nebulae is the Italian word for cloud, I guess, or whatever it was. Yeah. So that's what he thought it was a nebula.
Yeah.
And then it wasn't until we got a much better telescope.
Yeah. It wasn't until the person, Hubble, in the 1930s who realized that the galaxies were actually beyond our own and that's what they were. They called them spiral nebulae for ages because they just thought they were little nebulous spiral-shaped clouds in the sky.
So it's just been a little over 100 years since we're like, oh, there's a lot of galaxies, or at least just one. Yeah, that's when we started with the one. Right?
Yeah. But to your point about, what you're going to see, there is sometimes an issue that we have where you look at the planets and they're incredibly impressive, they're very colorful, and then we show you Andromeda and you're like, oh, that's it. And I'm still excited, but it takes a little bit more explanation sometimes and some mental preparation of you're not going to see what Hubble sees. You're not going to match the pictures that you're seeing in Google, right? But you are seeing it with your own eyes. That light traveled all the way to Earth just for you to see that galaxy. So while it may not look as impressive as the picture, you have to be willing to accept just, the whole big picture of what are you actually looking at? What are you seeing? And it's fantastic. It really is.
I think maybe a way to temper people's disappointments, like you said, is to stratify the order. Order that you do it. Like, okay, first thing, guys, we're going to look at is Andromeda. Yeah. That's a whole new that's our closest galaxy. You're 2.5 million light years, whatever it is. Like, that's the closest one, and blah, blah, blah. It's going to look like a smudge, and blah, blah. And then move on to, and there's Mars. And then move on to, look at Jupiter. Look at the moon. Like, check out the moon. And then let's look at Saturn. Like, you got to end like a closer. Like, you got to order this like a rock concert.
Yeah,
like
seriously.
You got to end with that because if you show me Saturn and Jupiter and then like I'm like like, oh,
Right.
I know, I'm just kidding. This is life changing. I can't believe what I'm seeing. And then you show me Andromeda, just a little smudge, but it is the craziest thing out there.
Oh, yeah.
That you're right.
But you have to be willing to appreciate it. You know?
Right. Yeah, but most people just want to we need that shock value. I think if you order it like, okay, this is the order, this is the order, this is the order, and then they end and walk away going, oh, I can't believe all of this.
Yeah.
Like I saw a galaxy and then I saw Saturn, and you're right. It looks like a sticker. Like you describing it looked like it's not real. Yeah. You feel like even when I was looking through my own little telescope, which I know nobody was messing with, I felt like I was being tricked. It's like, no way it looks like that. No way that thing is out there right now, that big, that far away, and that incredible. It's so pretty. It's so pretty. Oh, Valerie, yes. I get so excited about outer space.
Me too, I do. I could sit here for hours and just keep talking about it.
I know. I don't even know how to end this. I don't want to end it because I just want to keep talking about outer space because we can go so many directions.
I know.
What direction you want to go in now?
Really?
Like, okay, so back to the sunspot. These storms, do they look anything like the storm on Jupiter? The red eye? Is it that kind of swirliness?
Really. Okay. No, it's not swirly. It looks more like a literal dark spot.
Like a freckle?
Yeah, like a freckle. And then if you look really closely with the right kind of telescope, you can see there's little lines that go in. Because what's happening inside the sun is the magnetic field, basically this kind of shield generated inside the sun, is coming through the plasma. And it's stopping the sun from carrying the energy to the surface. That's why it looks dark, is because it stops the heat from coming up. And you're basically opening a hole, and then the material, the plasma, is trying to fall back into the hole, but it can't. So it opens this like dark hole, and eventually the plasma wins and it goes back to normal. But that's what you're seeing.
Do we know yet why the outer layer of the sun's plasma is hotter than the inside?
No. So they just launched, I don't know if you saw though, the Parker solar probe a couple months ago. Yeah. So that is hopefully going to help us answer those questions, because we really don't know yet. But the Parker probe is going to go all the way to the sun within 4 million miles, which sounds far, but it's actually like way closer to the sun than we've ever gotten. And it's going to sample that atmosphere. It's going to sample the corona and hopefully teach us something about the heat transfer and how it gets so darn hot in this very thin layer far above the sun's surface. It
boggles the mind. How is the outside hotter than the
right?
The inside?
It doesn't make any sense.
It makes no sense.
You know, and astronomers have come up with a whole bunch of different explanations. Like Parker, the astronomer, who the telescope is named after, his idea is that there's micro or nano flares, I think he calls them, where basically the sun has these itty bitty little bursts of energy that carry to the corona, the atmosphere, and then the energy is distributed. And we can't really see these bursts. They're just kind of energy at wavelengths that were not easily visible. So that's kind of his idea. And then there's other ideas about the magnetic fields carrying the energy and trapping other energy from outer space. There's like a whole bunch of theories, and we need to figure out why. And it's hard to believe that we don't understand our sun. Like it's right there, you know?
Right.
And we've studied it for so long, and there's still so much that we don't know.
Do solar flares kind of keep you up sometimes at night? Like sometimes, like I think about them fairly regularly. I'm like, oh,
you're like, I hope one's not coming today.
Yeah,
I'm looking out the window, waiting for the
just imagining something so simple, like it's like a sun fart, right? It's just like
yeah, basically,
and it will wipe us out.
Yeah,
like not murder, not kill us. Like our bodies will be kind of fine, even though we'll be blasted with a bunch of
you're not going to keel over on the floor instantly.
But it will wipe our civilization out for a while. We don't even know how long.
I mean, it's caused blackouts before. This wouldn't be the first time that there was just a total blackout of part of the country or whatever when there was a strong solar storm. The comforting part, though, is that, we're 93 million miles away and we're about this big compared to the sun. So the chances that, like, the direct heart of a solar flare is aimed exactly at Earth are very, very small. And that's, part of the reason why we've survived the way we are this long is the chances of one hitting us directly are slim. So
on any given day, they're slim. But over the long term, it's inevitable.
Yeah, I mean,
somebody's going to have to deal with it.
Yeah. We should be prepared just in case. And a lot of the energy companies are nowadays. They're literally making changes to the power grids to counteract that.
It's one of those things I'm not looking forward to, but I would love to be around for it.
Right. See, what I want to be around for is the magnetic field flip of the Earth. Do you know about this?
Go on, not from you.
So the magnetic field, right, the Earth has one just like the sun does. It's this nice shield, protects us from the wind of the sun and all sorts of nasty stuff. But we know from the geologic records that the magnetic field flips. And it has done so many, many times throughout the whole 4.5 billion year history. It doesn't appear to cause many issues, right? It doesn't cause global devastation or anything. But I forget how long it's been, but like hundreds of thousands of years since it's flipped. And it looks like from the record that we are totally overdue for a magnetic field flip. And I want to know what happens, because this is the first time in history that we have had technology and other things that are like related, that need the magnetic field, that rely on it. What happens when it literally flips upside down, when the North Pole becomes the South Pole and vice versa? Like, that is what I want to live through. Now, the Earth doesn't flip upside down. It just all happens internally, but still, that's got to screw up our technology and, you know, animals that rely on flying in the right direction. Some of them actually they have an internal compass. And they know what direction to fly and move. I don't know. That's the thing I'm looking forward to. It could kill us all, right? If we're picking things that are devastating but exciting, that's the one I want to see.
No, yeah, because I've seen on old. You're reminding me. I'm pretty sure I've seen this on. It described pictorially that the magnetic poles say would be, I don't know, like in the middle of North America, for example. Like, instead of being up at the top, it would now be in Kansas, and then the South Pole would be in China or something like that, right? That's essentially what you mean, is they flip, or they just move. The poles flip.
Well, so they're moving all of the time, but literally, so the current north magnetic pole is off from the actual North Pole of Earth by like 12 degrees or something like that. It'll actually go, so like the compass will now point south instead of north. It'll literally flip completely. But what happens in between is a big unknown. Does it migrate? Like, does it slowly move? Or does, like, something happen inside the Earth where, yeah, it's a snap of your fingers and all of a sudden my compass is pointing the wrong direction?
Whoa.
Well, nobody's lived through it, right? At least not human beings haven't lived through it, or modern day ones at least.
The ones that felt it and it
the
affected
ones
their
that
lives.
Noticed, you know?
Well, unless there were ancient civilizations.
Right, and it killed them all.
And it killed them all. Because
man.
of the tide, maybe the tides flip and everything gets flooded, and that's where all great flood stories come from.
Oh, of course.
Is the gravitational flip, or the magnetic flip. We just figured we better get your book going then.
Yeah, right.
Before this crap.
Oh my god.
I had a couple other questions. Oh.
Yeah.
Well, just speaking of like that, so there's things that like scare me and fascinate me.
Okay, go for it.
Because you reminded me of the magnetic flip. I hadn't thought about that one in a while, because my favorite are solar flares, because that's just like a quick bam, we have no warning, and what's up?
Right.
And what happens? The other one is, I don't know how many times a year I look at this. I just looked at it a few weeks ago again. The I forget the Russian name. The one that exploded over Russia like 5-10 years ago.
Oh, the Chelyabinsk meteorite.
There you go.
Yeah.
Oh, I love watching that footage.
Right.
I love that. It's shockingly terrifying.
Yeah.
It's so beautiful. And whenever I'm hiking or camping or something, I'm like, I would love to see that right now. But I would love to see it land in the ocean or just in the middle of nowhere like that.
Right. Not actually, not next to my house.
But we're like people say we're in a little shooting gallery, and then like I said when I was camping with my girlfriend, you just see all these things come in the Earth's atmosphere all the time. It's happening right now as we're speaking. Yep. There's how many things hitting us? Literally
tons of material smacking into the Earth all the time.
What?
Right? And I mean, some of it we know is coming. The big ones we generally know. But like with what happened in Russia, nobody saw that coming. Right.
And that was the size of
it was
this
huge.
This room, but it wasn't relative to the damage it caused. It wasn't that big, right?
Correct. Yeah. I mean, I think it was about the size of this room. You know, when it started to come through, when they finally pulled out the chunks that landed, they were maybe as big as this table, so like, I don't know, 4 feet wide or so. But I mean, that wouldn't have caused global devastation had it hit. But the beneficial thing is that it exploded in the atmosphere. It didn't actually, I mean, pieces struck the ground, but the whole thing didn't hit the ground. Had it done that, the city could have been leveled. Like, that would not have been a good thing.
You didn't have to end it with that. We know that would not have been a good thing.
That's true, right? Obvious.
The question that I've never heard asked when people say that, it exploding in the air and not hitting the ground, what determines if it's going to explode in the air versus hitting the ground?
Yeah.
Do we know?
So part of it is the composition, right? Is it a solid chunk of iron, or is it a different kind of asteroid that has more rocky material in it? And how porous is it? Some of them are very solid and they're going to make it all the way to the ground. They're not going to burn up very much. But if they're made of a more malleable rock material, then the pressure and the heat from coming through the atmosphere can literally burn holes. And if you force the energy through the holes of the rock, eventually the rock's going to explode. So it just depends on what kind it is. You don't want a giant chunk of iron to do that. You want something that's softer, that can, explode
a friendlier
more
asteroid.
Yeah, exactly. Exactly.
Is it mostly iron all the time? I feel like those are the only ones I've seen.
Yeah, so it depends. I mean, there's iron in most asteroids. It just depends on how much. So you have the solid chunks of iron that are basically the cores of asteroids, and then you have other asteroids that have sediments in them, essentially. So it's iron mixed with other minerals and rocky material, and it's more distributed. It just depends on how the rock formed in outer space. So you have both, and they hit the ground all the time, so there's collections of all different kinds.
This is so much fun. I'll let you decide, because if we keep going right now, I could just probably not shut up. Or right. What time are we at now?
Oh, we're about 1:30, so.
I could do another 10 minutes.
Yeah, we could chat a little more.
All right.
We should end on a happier note.
Yeah.
Right? I mean, I love talking about this stuff, so we can keep talking about it. But at the very end, something happy about space.
Do you? All right. So, is the idea we're gonna create this Mars, this Earth, this Moon to Mars thing? Is the concept to figure out how to survive on the moon and create a moon base, and that's like a base of operations to the next, like skip a rock or leapfrog, like if we're using like lily pads, like boom onto the moon, then boom onto Mars. Is that kind of the idea?
Not exactly. They thought about that back in the day when they were looking to go to Mars, like maybe a moon base would be the way to go. But I think they decided that the money and the effort it would take to go back to the moon and set up a moon base wouldn't be worth it. It actually turns out to be easier just to go from the Earth to Mars. So what they're doing is they're trying to study the moon more so we can learn more about the Earth and the solar system. And then they're going to send more robotic spacecrafts directly to Mars to help prepare for a human mission. So to drop off supplies and learn about radiation levels and the lack of oxygen and all the things that a human being would need when they get there. So we're not looking to build a moon base with it. We're just looking to gather as much information as possible in preparations for sending humans to another planet. Which is really hard to do, by the way. I just put a talk together on this, and it's like not easy to get people to another place and keep them alive, right? I guess it's easy to get people to Mars. It's hard to keep them alive humanely on the trip. That's what I've learned. Is we can send anything to Mars that we want to, but keeping them alive is
right. Oh,
right.
Well, we have the same problem with like Antarctica, right?
Sure.
Like, sure, we could get you to Antarctica anytime you want.
The plane can drop you off.
Dude, you're in Antarctica. Have a blast.
Right, but yeah.
But you're dead in 4 hours. This is a question my friend asked me 20-something years ago, early teens, mid-teens. He's like, hey, would you rather $1 million or to go to outer space? And I said almost without hesitation, I said, I'd rather the $1 million just because I have so much work more to do on Earth. Like, I'm not ready to go to outer space. Now I don't know. I still really like Earth.
Yeah.
I'd probably still stay here.
Sure.
Not even for the money, just I'd rather stay here because Earth is really sweet.
Yeah.
Would you want to go to outer space?
No. I have no real desire to be an astronaut. As lovely as it sounds and as much respect as I have for them, I'm going to cheer them on with my feet on the ground.
Right.
But a lot of people ask me that, and I think space is exciting and I love learning about it, but I don't know that I'm up for the mental and physical challenges of being an astronaut. It takes a very special person to be able to survive in those confined spaces and to stay calm during emergencies and just to handle everything that you need to handle as someone who's living in space or on another planet for that matter. I'm not sure that I personally am cut out for that.
I don't think I am too. Like, I just have too much fun down here too. Like, I'd want to have so much fun up there, but it seems like you have to be serious all the time.
It's very structured. Like, all the astronauts that go to the space station, every moment of their life is scheduled and structured. You don't just get to chill on the space station. You know, NASA has listed every specific thing that you have to do when you sleep, when you eat, when you do everything.
And that, I would guess it would probably go doubly if you're going to Mars, right?
Oh, like, I can only imagine.
Like, no. You really, if you guys lapse for 30 seconds, you're gonna die. If you forget to turn this crank a little bit to the left, every hour, you're gonna die.
Yeah.
That was something that I've heard astronauts talking about living on the space station. And they kind of, this one woman said that she just occasionally, if she gets a little bit of free time, she'll just look out the little glass window down at Earth, or look at the stars. Yeah. Was it cupola?
Yeah, that's what they call it.
And so she looks at the cupola. Is that Cupola? That seems.
I have no idea.
All right.
I just know what it's called. I've never actually written it down before.
All right. So that's, I spell words when people say them. When I don't know them, I just try to spell them, and then I try to remember them.
Right.
So she made it sound like it was so infrequent. Like, I was like, hey, yeah, if I could just get, like, a few minutes. Like, I think she said, like, 7 minutes of time.
To like, literally all she gets.
Look out. I'm like, this seems like it sucks. Like, this job seems like it's not fun. Which is why I think probably most of them are military people, right? Yeah. They start with the military structure, life,
yeah, I was going to say, they're used to that.
Yeah, it ain't me.
No.
It's definitely not me.
No. I mean, it's so cool what they do, and I love hearing their stories. I recently saw Nicole Stott. She was a local astronaut, and she came and give a talk up at SPAC, and it was great to hear her stories about what life was like on the space station and all the fun things she got to do, and the fact that they have so little time to just chill out and be human, you know? I believe she showed us a picture, I think it was her crew, of like over Halloween, they had brought costumes to wear on Halloween, and, you know, just those fun little silly things to make it a more humanizing experience.
That's got to be such a weird feeling to know that if you didn't bring it, it ain't there.
Right, you can't just run to Walmart, right? And pick up a costume or something.
Like, they had to think about that and find a way to pack it in addition to all the other really, really necessary things.
Sure.
But they know us jabronis down here want to see them dressing up, want to know that they're having fun.
Exactly.
Like, oh, look how cool it is. Because it's going to inspire, we always go back to little kids because that's what we do as humans. When we're adults, we always go back to, all right, how's this, anything we do, how's this going to affect little kids?
Exactly.
We're like, okay, Halloween outfits. This is for little kids to get their attention, to encourage the next crop of astronauts, the next crop of explorers, to show them that, hey, science is really cool and fun. Like, and it's not just, people used to say they wanted to be an astronaut, but I don't think they knew why they would say that. Like, little kids, like, I want to be an astronaut. Why? Because I want to go to the moon. But it's way more than that.
Sure.
It's way more than that. And you got to be really an exceptional person, like you said. Like, these are very, very rare people. And we gotta find them. And you're at the tip of the spear. You gotta find these kids walking around miSci.
Be like, you are the person that would survive on Mars. Not me, but you.
Right. Yeah, I wouldn't. Would you let your kid go to Mars?
If they wanted to. I mean, I'm sure I'd be the nervous mother at home going, oh my God, you have to call me every 10 minutes. I'm still alive, Ma. I'm still headed to Mars, still going.
Yeah, you can't get in the way of that,
but,
I guess.
You know, I think that would be an honor, I think, to have an astronaut as a child. That would just be amazing, you know. I think every parent wants to see their child do things that they weren't able to do, or they don't feel they had the power or the ability to do.
Or just the imagination to think,
right?
Oh yeah, or just that window of opportunity to be born at the right time, where we're developing not just the idea of fantasy of going to Mars and traveling to other planets and maybe living there. It's like, no, we got the pieces. We're setting up the chessboard, and we can play, and we can actually get there.
We can make it happen.
Yeah, it's part of the reason I want a kid, so I could like hone him into doing some really cool things.
Cool.
Yeah.
You never know. That's the cool thing with every child. I love to just look at the kids and think, you know, what are you going to be someday? Because every child is going to be somebody. And there's so many wonderful things that these kids are going to do for us. It's exciting.
I like to reverse engineer that too. I like to see adults and like think back, what were you like when you were a little kid? And how did you get there? And are you still that same little kid inside? Like, does that kid exist anymore?
Sure.
Because I know for me, when I reverse engineer myself, I'm like, oh yeah, I'm basically the same person I was when I was 7 years old. Like, I have the same thoughts.
Right.
I don't know if that's a good thing. Right. I don't know if that's a good thing, but no, I was like, oh, I used to have these thoughts as a 7-year-old, and I'm like, oh, I still have them now. But then I talk to other adults, and I'm like, I don't think you were ever a little kid. You don't seem to be a little kid. You don't think about this stuff. Mm-hmm. I don't know. But yeah, you're right. It's like I see my nieces and my nephew, and I'm like, like, what can I do with you? Mm-hmm. Like, what are you here for? Yeah. What do you want to do? Mm-hmm. Because I don't know, the world's way different now, and it's way cooler because you have such an access of information. Mm-hmm. And make a case, we have too much access to information. Yeah, right. But it's definitely way more good than it's bad. And then there's people like you who are like putting out that good info. Yeah, like I said, outreach astronomer is such a hybrid title. Yeah. You're kind of a hybrid person. Mm-hmm.
That's really the goal. People, when they see me, they're like, you have a PhD? And I'm like, yeah, but I can talk to you. And that's okay, you know, because they're just astonished because they expect me to be a different kind of person when they hear about my background. And, you know, I think they're excited, hopefully, to see that I can actually talk to another human being and relate to them on a human scale, because I'm not just all about science. I do other fun things as well, you know. Had I not told you I was an astronomer and you were hanging out with me one evening, you know, you would never know. I mean, except for the dorky astronomy things hanging in my house. And, you know, those kind of little touches, my bumper stickers, you know, that kind of silly
What's
stuff.
Your bumper sticker?
So I have, it's not a bumper sticker, it's a plate outliner thing, and it says, trust me, I'm an astronomer.
I love that.
It's the best.
That has to be a weird thing for you, too, though. You have to come across that if you're just, say, meeting someone on the street or just a grocery store or a picnic, and they know nothing about you, and you're just chatty. Yeah. Somebody could be talking to you for 20 minutes or something, and then somehow...
Yeah, what do you do?
Yeah, that's like the most vomity question in my life. Mm-hmm. First time I heard that, I'm like, people really just talk about what they do? Like, this is so boring. Right. But people do it. Mm-hmm. I know it's what everyone does. So when they get that question, is it like a record scratching? Yeah. Like, what? Music stop? Like, wait, what?
Well, a lot
I didn't think you were that, like, so then could you see, like, them just starting to judge? Yeah. I shouldn't even say, like, it's a bad thing. Like,
no, I know
whoa,
what
you really smart? Wow, you're really smart. I'm overwhelmed in this. I shouldn't even be talking to you anymore because you're probably really smart.
The problem is like, I tell them what I do, and they don't really know what to say back, because if I say I'm an astronomer, an astronomy educator, like, they don't know how to respond to that. You know, if I say I'm a doctor or a lawyer, they know what that means. They know how to ask me questions, but they stop often. They're like, oh, that's really cool. And then I think they want to ask, like, so what do you really do every day? You know, it's like, are you gazing at constellations? Are you teaching? What are you doing? So it always has to be a further conversation. Like, I'm an astronomer and I teach kids all about science. You know, I just have to add the little bit about, this is who I am and this is what I do, so we can keep the conversation going.
Right. So, because there's no...
They don't get it, you know?
There's no real follow-up to that because it's so unrelatable to most people, because that's like that's not the answer people give. Right. No one's ever said that to me before. Exactly. I don't know where to go. Exactly. Oh, God, do you need another drink? I'll be right back. And conversation over, right?
And they don't mean it to be rude. It's just like they just don't know how to respond to that.
How did you meet your husband?
Yeah, so we met as kids. We were actually on the same bowling league when we were 12 years old. So we met that way, and we were friends for a long time. We started dating when we were 16, and we've been together ever since.
Ooh, you got so lucky.
I did, you know.
You got so lucky because...
I never planned that out, right? You never really plan to stay with someone when you're 16, and looking back, I'm like just shocked that it actually worked out, because for everybody else, it hardly ever works that way.
Right. I've been with my girlfriend since we were 18, 19. Right. We're working on 19 years together now. Yeah, it's crazy. It's crazy.
And I was such a different person when I was 16 or 18 as I am now, too. And we definitely, I could see us have evolved together, you know? And he's the total opposite. He works for Homeland Security. He's a firefighter for the state of New York through Homeland Security. So, you know, you've got an astronomer and a firefighter. And I think that's the cool piece to tell people, because then they're like, how the hell did that work out, you know?
Yeah, that's the path that people can mostly understand. Right. But to just what I was thinking about, you interacting with these people not knowing what to do with an astronomer. Yeah. I have several friends that are really smart women, and they have a heart, and they're single. They didn't meet guys when they were 12. Right. And they just can't find a guy that they can relate to, because guys are like, what? Like, I don't understand what you do. Like, you're some are lawyers, some are doctors, and it's like, they don't know what to do with that kind of smart, like, I don't know what to do. I've never met such a smart person. There's that intimidation factor that You just...
Sure.
So I knew there had to be some kind of story behind you and your husband.
You know, and he keeps me grounded too. He helps me with this communication because, you know, not that I'm not a normal person, but I'm definitely different in some ways, you know, with the whole astronomy thing. And he has helped me over the years, you know, be able to communicate with people. So I get to hang out with his friends and people that have normal jobs and learn how to share with them what I do and how to give that, you know, 30-second elevator pitch where people will keep talking to me about what I do. So he's just the best. It's been great.
That's a great way to utilize your husband, I guess. To use him is like, hey, show me what normal people talk about.
Exactly.
Because I'm a little weird.
Yeah.
But hey, this is a lot of fun. I love talking this outer space stuff with somebody who loves talking and loves little kids too.
Right.
And your job is basically, see, the other side is, you know, we talk about the most science geeks, whenever they are. Nerds is it's a good word.
Yeah,
it used to not be such a good word for whatever reason.
Right.
But nerd is a good word. A good nerd that can communicate, because most nerds just take that, they want nothing to do with people.
Exactly.
But you got your education, you use your brain, and you're just sharing it.
Exactly.
Like sharing
That's
that knowledge instead of just, you know,
Yeah.
hunker down, which we need those people for sure. We need them. But we need a lot more of talkers about this.
Agreed. I hope to inspire more people to follow my path and just do that. Just share with people what you do.
All right, you finish it. Invite people to miSci.
There we go. Yes, come to miSci, right? Come see the observatory. Thursday evening, 6:30 to 8. Sundays, 1 to 2:30. I'll be there. My fellow astronomy educators will be there. It'll be awesome.
And the next big event is what?
Yeah, Science Festival, right? October 5th through the 8th. It's over Columbus Day weekend. So come to Science Festival. The observatory will be open a couple times, but there'll be literally wall-to-wall science. So much cool stuff to see.
And snakes that you put through the thermal.
And snakes in the thermal imaging.
I love that. That's so smart.
That's cool, yes. Come
All
to
right.
the snakes.
Thank you, Valerie.
This
has been a lot of fun again. Goodbye, science nerds.
Woohoo.
Bye. Oh, I could talk about this all day long. All day long.
Great.
I love this. And you drank your latte.